Hi, this is Rick for EDU Mobile. Now we're going to talk about view animation, or tween animation as it's sometimes called. View animation properly is only used for very simple animations. When we get a little bit more complex, we want to go to property animation. And I'll tell you why at the end of this discussion. But let's go ahead and discuss view animation for now. View animation is used to perform one or more, again, simple transformations to a single view. And the possible transformations we can perform are rotation, scaling, translation, matrix transforms, changing the alpha value as well. Simple transformations. Now, view animations may be defined entirely in code, but usually for portability, we define them in an XML file. And we put this XML file in the resource animation, or anim, directory of a project. Now, the animation XML file, like all XML files, needs to have a single root element. The elements that perform animation are alpha, scale, translate, and rotate, and we can group those up again into sets of animation. Now, we can control the time that an animation starts by using a start offset. We can control the duration. We can use interpolations and so forth. So in addition to other properties, every animation's starting time and duration are specified, which allows for either sequential or simultaneous animation. So here's a single animation, a rotate transform, which will rotate a view through an angle of 180 degrees about its center point over a period of 1 second. So from degrees to degrees shows you the rotation part. The pivot is the point about which the rotation will occur. 50% just says halfway in the X and halfway in the Y. This rotation will occur about its center point, and it will last for 1 second, 1,000 milliseconds. Android duration sets that period of time. Here's another animation. Multiple animations require a set. We group them up into a set of animation. So this scales a view down for half a second and then fades it out for 3/10 of a second. So we have a set and we have scale and alpha. The from X scale and from Y scale are 1.0. We could also use 100% here. The 2X scale and 2Y scale are 0.5, which means that it will scale from its full-sized initial value down to half of its initial value in both the X and Y direction. The duration is 500 milliseconds, half a second. Then the alpha kicks in after the scaling does. So from alpha is 1, fully opaque. To alpha is 0, fully transparent. Start offset is 500 milliseconds because the duration of the scale animation was 500 milliseconds. So we want to start after the scale animation has completed, and then the duration is 300 milliseconds. That's 3/10 of a second. So we can also animate simultaneously. This would scale a view down for half a second, as we did before, exactly as we did before, while fading it out. So the scale animation from X and Y 1 to X and Y 0.5 scales it down by half over a duration of half a second. And then the alpha animation from alpha to alpha 1 and 0, start offset here is set to 0. And then and/or duration 500 means it will take the same amount of time as the scale animation and start at the same time because there's no starting offset. Of course, we can omit this attribute. We could omit Android start offset entirely, because if we don't have a start offset, the two animations, or the alpha animation, won't be offset in time from the scale animation or any other animation. It will start at the beginning. We can also interpolate. Several of these interpolations are available. What's an interpolation? An interpolation is determining how an animation will be applied over time. Does it start slowly and speed up? Does it start fast and slow down? Does it speed up then slow down? How is the time interpolated? And there's an attribute for this. Android : interpolator, whatever. The most common, and notice these are all in the same namespace, Android : anim /. The most common are accelerate interpolator, meaning it will speed up, decelerate interpolator, meaning it will slow down, and accelerate decelerate interpolator, meaning that it will speed up at the beginning and slow down toward the end. So now we execute the animation. Once we have the animation resource file XML in res anim, we can apply it to a view in our code. So here we're getting a text view, find view by ID, as we've done hundreds of times before probably, and then we set up an animation. An animation is an object of class animation. So here we're calling it TV animation. I use animation utils dot load animation, and then we need a context, this, and then the animation XML file, the path to the resource, r.anim.myAnimation, whatever we call it. And then finally, we start the animation. TV dot, and that's our text view, dot start animation with the name of the animation we're going to apply to it. Again, view animations only animate the visible aspect of an element, nothing else. They don't animate properties. The actual properties of the element are not changed. So when the animation finishes, if you don't finish at the same place you started, the element will revert instantly to its actual position. Rotation, scale, alpha, it'll all go back to what it actually is by its properties. So to change the underlying properties, well, not quite true. We could go through and change those properties when the animation finishes, but we can't do that in the XML. We would have to do that in code. It is much easier to just animate the properties in the first place, and we can do that using property animation, which is the topic of the next discussion. Thank you very much.